Alright, the last section of the review, or last three sections, um, multiplying and dividing complex numbers, DeMoivre's theorem, and stuff like that. I will give you these formulas right here for the test, so you don't need to memorize these, but you do need to know how to use those formulas if you see a problem like this. So for part H, you're supposed to find Z times W and Z divided by W. And let's do Z times W first. Z times W. I'm looking at my formula. If you multiply two vectors, now I have them Z1 and Z2, but that's the same as Z and W. You multiply the two R's. So it would be 3 times 4. And then the cosine of, and then you add the two angles, so 100 and 120. So 100 plus 20 to 120. And then plus I sine of 100 plus 20. And that would give you 12 times the cosine of 120 degrees plus I times the sine of 120 degrees. And so there's your answer for Z times W. Z divided by W. Almost as easy. I would say it is as easy. Following the formula, you divide the R's, so Z divided by W, I would do 3 divided by 4. And then we subtract the angles, so cosine of 100 minus 20 plus I times the sine of 100 minus 20. And then we'll clean that up, 3/4 cosine of 80 degrees plus I times the sine of 80 degrees. So there's our answer. I do wish, when I was writing these problems, that I had done W divided by Z instead. And the reason I wish that I'd done that, I'll do it very, very, very quickly in this big block. Extra problem. What in the world did I just spilled there? Problem. Extra problem. If I did W divided by Z, you follow the same formula, except now W is going to go like top. Say 3 divided by 4, it'd be 4 divided by 3, and then it would be the cosine of, and we'll do 20 minus 100, which is actually negative 80 degrees, plus I times the sine of negative 80 degrees. And negative 80 is a problem, because for these problems, I do want your angle to be between 0 and 360. So if you did get a negative angle, or if you got an angle that was over 360, then you would have to adjust for that. In this case, I will add 360 to both of them. And that would give me 4/3 times the cosine of, let's see, 360 minus 80 is 280. Plus I times the sine of 280. So be aware of that if it happens to show up on the test. That when you're doing these things, I don't want your angle to be between, I do want your angle to be between 0 and 360. So just in case that shows up, you have to do that. Section I, let's see, this is DeMoivre's theorem, where I want you to raise this thing to the power of 4. And following the formula down here, which I will give you, I'm going to give you this formula. Following that formula, real simple. It's this stuff to the 4th power. So if I want something to the 4th power, this is just that formula, but with n equal to 4. So that's going to be, you do your r to the n power, so 3 to the 4th power. And then it would be cosine of 4 times pi over 4 n times theta. So 4 times pi over 4 plus I sine 4 times pi over 4. And then we'll clean that up. 3 to the 4th is 81 times the cosine of pi. The 4's cancel. 4's cancel here too. Cosine of pi plus I times the sine of pi. And then the one thing that I almost missed is it does say, write the following expression in rectangular form. I want my answer in rectangular form. So I've got to get out of polar into rectangular. Now that's pretty easy because all I'm going to do is look at my unit circle. I need the cosine of pi and the sine of pi. Pi happens over here where my coordinates are -1 and 0. The cosine of pi is -1 plus I times the sine of pi, which is 0. And then we'll simply distribute the 81 through that. So 81 times -1 plus 81 times 0i is still 0i. And that would be your answer. You don't necessarily have to put the 0i, but I put it there just to kind of remind myself that we are dealing with complex numbers. So there is DeMoivre's theorem. And then the very last problem, which is a beast of a problem, finding any root of a complex number. And this one's really tough because I gave it to you in rectangular form, but this formula, which I will give you on the test, is in polar form. So my first thing to do is convert -8 minus 8i to polar form. Since we just did, what is wrong with my writing today? Since we just did 3 problems on this in one of the previous sections of the review, I'm going to pause the recording while I do this. So hang on just a sec. Alright, so there is all the work, and this is what the polar complex number turns into for polar form. So now I rewrite the question, or rethink of the question as find all the complex cube roots of, and instead of -8 minus 8i, we'll just scratch that out and we'll find the complex cube root of this polar complex number that we just got using this formula. And the way I do it is I create a table where I plug in, and for this we plug in different values of k. I do know that since this is the cube root, that's the third root. That's the same thing as the third root. If it was the square root, that would be the second root. And since it's the third root, we know that n is equal to 3. So in this formula, we're going to take out n, and we'll plug in 3. So I create a table where I have different values of k, and then I know that my answer is going to be the third root of r, which I know r is a root 2. So this is the third root of 8 square root 2 times the cosine of my angle, which my angle is 225, plus 360 times k, and we'll plug in different values for k, all divided by 3, plus times the sine of that same angle, 225, plus 360k, all divided by 3. And I'll create a table where I plug in different values for k, and the values you plug in, you always start with 0. So I'll plug in 0. And then if it's the third root, I'll plug in 3 numbers. So I'll plug in 0, 1, and 2. That's 3 numbers, and you always start with 0. So this is the table that I'm going to fill in. And so for my very first one, I'm not going to try to clean up the cube root of a root 2. Then it would be the cosine of 225 plus 360 times 1, or times 0, all divided by 3, plus times the sine of 225 plus 360 times 0, all divided by 3. And then we simply plug in those ugly fraction decimals to a calculator to get a nice clean answer. What is that? No, don't restart. And when you punch in all of this stuff right here, you get 75. So all of that equals 75. So what I'll do, I'm going to leave that there just in case people are only looking at the answers. So I'll leave that one at 75, but then for the next one over here, since I already know all that stuff's going to equal 75, this one's going to be the same. So it'll be the sine of 75, and then I'll just bring all of this stuff close to it. But then we repeat, do the same thing with 1, and we'll repeat and do the same thing with 2. So the cube root of 8 square root of 2. And then it's the cosine of 225 plus 360 times 1, all divided by 3. And I'm going to go ahead and punch that in right now. And when you punch that in, you get 195 degrees. And it's going to be the exact same angle for sine, so that equals 195. And that's the same angle that you'll have for sine, so it'll be I sine of 195. And then my final one, the cube root of 8 square root of 2 times the cosine of 225 plus 360 times 2 all over 3. And when you punch that in, you're going to get, I think, 315. But let me check and make sure. Hang on a sec. Yeah, I was right. It is 315 degrees. So all of this is equal to 315. And so for my sine one over here, rather than punching it in the calculator again, I'll just go ahead and say 315 degrees. And those are your 3 answers. You actually do have 3 answers for these problems. These are beastly problems. These are your 3 answers. Right here. So whatever root you're looking for, since I was looking for the cube root, we got 3 answers. If I was looking for the square root, there'd be 2 answers. If I was looking for the 9th root, there'd be 9 answers. So I got a beastly problem. I will make it a little bit easier for you on the test. I will start you off with a polar form. I'm not going to make you convert to polar first before using the formula. So don't worry about having to do this in addition to finding the roots. Now you do still need to know how to do this, because I will ask you to convert a complex number to polar form, but that'll be all you do for that problem. You don't have to then go on to do this. So there it is. I think that is everything on the review. Hopefully this will help.